Hello, welcome to Source classes. Well, this particular question is from natural products and memory-based question. So this is a muscone given over here, and they have asked what it is. We will call this as a polyketide. So there is nothing much more to explain over here. Okay, it's just recognizing the molecule which belongs to where. The next question that we have. Okay, here we have a natural product that is given. It is giving a signal at 218 ppm in its 13C spectrum. Now all you need to do is draw the structures with alpha pinene. We see that it is coming, it has an unsaturated bond. Here the camphor has a C double bond O bond. Carbon will be having a alpha beta unsaturated ketone and C double bond O. So this value will be lower than that of 218 ppm. Okay. Here we have the geraniol, which is having unsaturated bonds. So it is only for C double bond O and not saturated, not having a conjugation with the alpha beta unsaturated thing. Okay, so that only, then only it will be having, we will say this 118 around ppm or 120 around ppm. Okay, so point to remember here is carbonyl groups, when they are not conjugated with a double bond or a triple bond, then only it will have the value of C13 at around 118 to 120. So our answer over here will be camphor. Okay, now this is the last question, I believe. Here in question number 45, interesting question. The correct order of stretching frequency for carbonyl stretching frequency for the following compounds over here. We have to find out. Now see here, this is a regular sp2. This carbon is sp, not sp2. This is sp2, but here the internal angle is around 60. That means these bonds are having more p character. So if it is sp2, these are having more p character, then this will be having more s character. If it is having more S character, that means these are shorter or nearer to nucleus. So this particular bond will be having a higher stretching frequency than this particular C double bond O group. So we can say as the S character increases, the CO double bond stretching frequency will be raised. Because S character means shortening of the CO bond. The more the CO bond is going to be shortened, we know the formula from the Hooke's law that stretching frequency is directly proportional to the force constant. Okay, and that is 1 by 2 pi root over K by mu, which is reduced mass. So if K increases, frequency will increase. What did I say? Shortening of the bond. How the bond is shortened? By S character. So this is having the most S character because this is purely SP. Okay, here there is increase in S character because of angle strain. Inside it is 60, so more S character over here, less S character over here. But here, sp2 is more or less same over all the bonds. The S character is more or less same all the bonds. So over here, this will be having the highest frequency, followed by this and followed by this. Okay, so this B followed by A, followed by C. And I hope this answers all the questions that we had in the section B. Keep visiting Saurabh classes. We will be discussing section C in the next part, and hopefully you're enjoying the videos, and thanks for listening. Have a great day.